Hey guys, it's Mrs. Bryant. Welcome back to Flip Video. Before we begin today, I need you to press pause and make sure you have the two yellow sheets that are going to be your foldable in your ISN that I gave you in class today. Once you have those two papers ready and are ready to continue this lesson, you may press play and we may begin. So today, let's get radical. We are going to be talking about radicals. Some fast facts. The numbers below are called perfect squares. And why do you think that is? Well, if you remember the definition of a perfect square, it is the product of one factor multiplied by itself. Okay? And you don't need to have that memorized, but you kind of do need to know and remember what a perfect square is. So some more fast facts. Fill in the missing values in the table, and you should be able to do this really quick. 1 squared will get you to 1. 2 squared got you to 4. 3 squared will get you 9. This is 4. 5 squared, 25. 6 squared will get you to 36. 7 squared gets you to 49. 8 squared gets you to 64. 9 squared gets you to 81. Square root of 100 got you 10. Square root of 121 would get you 11. And 12 squared would get you 144. And that is something you should know off the top of your head being in algebra. So if 3 squared equals 9, then the square root of 9 is 3. What do you see and what do you notice? Well, you notice that once you take the square root of, this is called a radicand, you have the same thing that you squared. And this should all be a review of previous math. So the square root of a number is one kind of radical and a special family of numbers. This is the radical sign, and this number is called a radicand. Use the pattern to fill in the missing table. Square root of 1 equals the square root of 1 squared, which equals 1. Square root of 4 equals square root of 2 squared, which equals 2. Square root of 9 would be 3 squared, so this equals 3. This would be 16. 5 squared, this would be 6 squared, so that's 6. This would be 49. 64. 8 squared equals 8. Square root of 81 is the square root of 9 squared, or 9. Square root of 100 equals 10 squared, or 10. Again, this should be a review of previous math. So before we begin simplifying, let's remove factor trees. And you'll see that I've already worked this. I should have cleared it off before we began the lesson, so let's do that. There are two ways to factor 45. You can do 3 and 15, or you can do 5 and 9. I start with 5 and 9. And then I know that 9 is not prime, so I know it can be broken down to 3 times 3. I also bring my 5 down, so I know that this is my prime factorization of 45. So it says, what is your prime factorization of 45? 45 equals 3 times 3 times 5. So let's see what we're going to do with that stuff. Simplifying radicals. How do the prime factors of 45 help you simplify a radical? When you find the prime factorization of 45 and you take the square root of it, a pair of numbers means you have a perfect square. So the square root of 3 times 3 equals the square root of 9, so that equals 3. So you can just take it out. So the 3 comes out, and your 5 is left underneath the radical. Let's look at another example. Remember, you can use a factor tree to get the prime factors, and you need to do that on extra paper or off to the side. But the prime factorization of 60 underneath the radical would be 2 times 2 times 3 times 5. So remember, a pair means a perfect square, and you pull it out. But what you do with what's left underneath there, you multiply them together. So you pulled that 2 out, and 3 times 5 got you the radicand of 15 underneath the radical. Lastly, on this problem, there is already a factor outside the radical. 5 square root of 18 equals 5 square root. Prime factorization of 18 would be 9 times 2, or 3 times 3 times 2. Because this is a perfect square, you pull it out, And you are going to multiply what's outside together and leave what's inside the radical alone. So your answer, or your simplified version of this radical, would be 15 square root of 2. You simplify as normal, but then multiply the two factors outside the radical together. So simplify the following radicals in your foldables. Go ahead and get the one out that has the 4 lines. Your first radical is the square root of 180. So to start this, you need to do the square root of 180. There should be plenty of room. You know the easiest one is 18 times 10, and that would be 6 times 3, 5 times 2, and these are prime, so I circle them. 6 is not prime, so I have 3 times 2. Those are now prime, and I bring all my primes down so they're all on the same level. Now, so we are going to have the square root of 2 times 2 times 3 times 3 times 5. This is a perfect square, so I can pull it out. This is a perfect square, so I can pull it out and leave the 5 underneath. So 2 times 3 equals 6 square root of 5. And this is your simplified version of the square root of 180. Press pause until you have it all copied down, and then press play and we'll move to the other one. So what is the square root of 294, or the simplified version of it? So first things first, find your prime factorization. I don't have my calculator, so I'm going to start with 2. 294 divided by 2. So it's 2 times 147. 147 divided by 3, I don't know if it works. It does work. So I have my 2 times 3 times 147 divided by 3. Notice that I'm showing my work if I don't have a calculator. That's 12, so that's 27, that's 49. These are prime, but I'm still not done with 49. That's 7 times 7. Bring down my primes that I already found, and now I have all 4 primes, so I can stick them under the radical. 2 times 3 times 7 times 7. Perfect square, so you can pull it out. 7, and there's nothing else to pull out, so 2 times 3. So I have 7 square root of 6, and this is the simplified version of the square root of 294. Next example, you'll notice that you already have a perfect square on the outside. So we need to take the prime factorization of 175. I know I have a 5, but I also know 25 can fit in there. So 25 can go in 175 7 times. 7 is prime. This is 5 times 5. Bring down my 7. Once I have all primes, stick it under the radical. 4 square root of 5 times 5 times 7. Perfect square, so you can pull it out. 4 times 5, square root of 7, so you have 20 square root of 7 is your simplified version. And last example, 7 square root of 108. So we're going to take the prime factorization of 108. That's 2 times 54. 2 is prime. 54 is 2 and 27. 27 is 9 and 3. So now I have all primes. I can pull my perfect square, or stick them under the radical. 7, 2 times 2 times 3 times 3 times 3. You can only pull the pairs out. So 2 and 3 can be pulled out. 7 times 2 times 3, square root of 3 equals 42 square root of 3. And that is your simplified version. Now, get the other foldable out and fill in your blanks based on this slide. Simplifying radicals, and here are the steps to do that. Write the prime factorization of the randican. Circle the two identical numbers, the pairs. The numbers from each circled pair will show up outside the radical one time. Even though you're circling two, you're only going to put it one time. Anything left uncircled will remain underneath the radical, and if everything under the radical symbol is circled, the radical will disappear. Multiply, last step, multiply the numbers outside of the radical together, and then you stick them together and you will have your simplified version. So, on Friday, when I have a sub, you will practice your simplifying skills on the radical remix. You will also have something else to do that day about radicals. I'm not sure what the title is, but the sub will have it for you. Make sure you have these foldables ready on Friday so you don't need to ask any questions. And enjoy this joke, and I'll see you in class tomorrow.